All right, today we're going to start Unit 5, Lesson 1, Earth's Days, Years, and Seasons. Your standards are 621 to describe and model how the position, size, and relative motions of Earth, Moon, and the Sun cause day and night, solar and lunar eclipses, and the phases of the Moon. We won't cover phases of the Moon in this lesson, but we will in the future lessons. 6.2.5 is demonstrate that the seasons in both hemispheres are the result of the inclination of the Earth, meaning its tilt on its axis, which in turn causes changes in sunlight intensity and length of day. Let me remind you to be filling out your visa and your notes as you go along. Make sure you get a signature and have it ready to turn in the next day. Spinning in circles. What determines the length of a day? Each planet spins on its axis. The spinning of a body, such as a planet on its axis, is called rotation. We've already talked about this, we've studied this, we've learned how Earth and Venus have different rotation periods, how Venus is much longer to rotate, and Earth rotates every 23.56 hours, 23 hours and 56 minutes. And the time that it takes a planet to complete one full rotation on its axis is called a day. So that means we've seen sunlight and nighttime. Earth rotates in a counterclockwise motion, remember prograde rotation, around its axis when we look at it from the North Pole. As a location on Earth's equator rotates from west to east, the sun appears to rise in the east, cross into the sky, and set in the west. Only one half of Earth faces the sun at any given time. People on the half of the Earth that are facing the sun experience daylight, and we call this daytime. People on the half of the Earth that are facing away from the sun experience darkness, and we call this nighttime. Earth completes one rotation on its axis in about 24 hours, or 1 day. So how does Earth's rotation make the sun appear to move across the sky? So if we're moving west to east, it appears that the sun is rising in the east and setting in the west. So you are about here on this map, about here. So as we're turning counterclockwise, the east will see the sun first, right? We're turning into the sun. Here's the east coast. Here you are. And so that means as you're turning into the sun, you're going to see the sun come up on this side. It's going to look like it's moving across the sky, and it's going to look like it sets over here to your west. But in reality, we are the ones moving. As Earth rotates on its axis, it revolves around the sun. Remember, a revolution is one birthday. So the motion of a body that goes around another in space is called revolution, one time around the sun. Earth completes a full revolution around the sun in 365 1/4 days, or about 1 year. We've divided our year into 12 months, each lasting between 28 to 31 days. What determines the length of a year? The length of a year, I would like for you to pause this and try to write your answer on your notes right now, and then unpause me and I'll give you the answer. The length of a year is determined by how long it takes a planet to revolve around the sun. One revolution around the sun, or one birthday for us, is a year. Tilt-a-whirl. What conditions are affected by the tilt of Earth's axis? I bet you could already answer this. Earth's axis is tilted at 23.5 degrees. During each revolution, the North Pole may be tilted toward the sun or away from the sun. When the North Pole is tilted toward the sun, the northern hemisphere has longer periods of daylight than does the southern hemisphere. We call that our summertime because we are in the northern hemisphere. When the North Pole is tilted away from the sun, the opposite is true. So we have shorter periods of daylight hours than the southern hemisphere, and we know that as winter. What conditions are affected by the tilt of Earth's axis? Well, I want you to look right here. You are in the northern hemisphere, so you're up here. During this period, when the Earth is in this location around the sun, you can see that the northern hemisphere is tilted more towards the sun. This is a picture of the northern hemisphere experiencing summer. Okay? Now come over here. Here's the tilt. See the red? That's the axis. Now we're in the northern hemisphere. We are tilted away from the sun. So during this period, we get less daylight hours with sun, and the sun is in a lower angle. So we are experiencing a winter here. It's cooler. There are cooler temperatures during that time. The angle at which the sun's rays strike each part of Earth's surface changes as Earth moves in its orbit. When the North Pole is tilted toward the sun, the rays actually strike the northern hemisphere more directly, so the region is warmer. So again, we're tilted toward the sun, we're getting more direct rays, and just that much difference, that little tilt away or a little bit towards the sun, causes us to have different seasons. When the North Pole is tilted away from the sun, we're going to have sun rays striking our northern hemisphere less directly, so it's making our region cooler. So we're not getting that direct sunlight, it's more of an indirect sunlight. If you actually take a look at the sun today as you're leaving school, in the sky, it's at a much lower angle than it is in the summer. And that is because right now we are in that winter period where the northern hemisphere is tilted away from the sun, so we're getting less direct sunlight. The spherical shape of Earth also affects how the sun warms up an area. At a point near the equator, the sun's rays are going to hit the surface more directly, and the temperatures are going to be higher there, and it's going to be consistently hit more directly. So their temperatures are going to stay right around the same place all year. They're not going to have seasons as much as we do. At a point near one of the poles, the sun's rays are going to hit the Earth's surface less directly, so their temperatures are going to be lower there. Even though we may be tilted toward the sun in the northern hemisphere, let's say, the rays are still going to be a little bit less direct there during their summertime. So that's why you go to Alaska in the summertime, it's not the same temperature as here. They're not getting as direct of sun rays. Okay, so here's a picture. If you look at comparing the area over which sun's rays are spread, the equator and the poles. So let's look at the poles. So look how much less direct. So if this is warm and this is getting, by the time it hits, it's not as direct, it's not as warm. So you can notice here, this is about where we would get it, right? That's about where it's going to hit Indiana as it travels around. And then you have something closer to the equator. They're going to get a more intense direct sunlight, more intense direct sunlight here, and less intense direct sunlight down here, even at the time in which the sun is facing towards, or the northern hemisphere is facing towards the sun. The number of daylight hours on any given day of the year varies with the location. You know this, you experience this. We're in a time where we're getting less daylight hours. It gets darker faster right now because we're in that away from the sun location as we travel around the sun. Areas around the Earth's equator receive about 12 hours of light a day, and that's always because it's going to be the sun's rays are going to hit them more consistently at the same spot because they're less affected by the tilt. I want you to look at page 248 and do questions 8 and 9. Apply which location on the illustration of Earth below receives more direct rays from the sun, A, B, or they receive equal amounts, and then identify which location is cooler, A or B. Areas on Earth's surface that are tilted toward the sun have longer than 12-hour days as they travel a longer path through the lit part of the Earth. That would be in our summertime. Sometimes it is 9 o'clock and there's still sunlight out. Areas on the Earth's surface that are tilted away from the sun have shorter than 12-hour days as they travel a shorter path through the lit part of Earth. That would be right now. It gets darker much quicker. At this point, we are growing in how many daylight hours we get, but still it's much less than in the summer. All right, look at the picture below. Which place has the longest days, which have the shortest? Let's just look at this picture for a minute, and then you can see if you can answer that. And you look at the person standing here. They are in total sunlight as they take their trip around. Maybe it would look like maybe dusk right here, but then it would get bright again. Okay, so this is summertime in the North Pole. And then down here we have wintertime in the South Pole, where they have a tiny bit of sun here, but most of their day is spent in darkness. Okay, now let's go over here. You can see the trip around the sun as we're pointed, as the axis is here. If you go day to night, you're going to have a little bit of darkness, but mostly light here. And again, their light hours are growing because they have a little bit more here, but still mostly darkness. And then you've got this right here, this individual, and this individual. They have a few more daylight hours, it looks like, here and over here. But they're going to be in the sun, or they're going to be in the darkness for most of their trip too. Interesting. During the summer in the northern hemisphere, areas north of the Arctic Circle receive 24 hours of daylight. So that's what that picture was kind of showing you there before. North of the Arctic Circle are going to get 24 hours of daylight, all daylight. Northern hemisphere in the summer, places like Alaska can receive 24 hours of daylight. At the same time, the areas in the south of the Antarctic Circle can receive 24 hours of darkness. And of course that is vice versa for northern and southern hemisphere, as the northern hemisphere is pointed away from the sun in its trip. In the winter, the northern hemisphere, the polar areas experience the reverse conditions. Okay, look at number 10 on page 249. Try this. Synthesize. Why isn't the area of the photo very warm, even though the sun is up all night long? All right, let's talk about seasons. Seasons change. What causes seasons? Most locations on Earth experience seasons. Each season is characterized by a pattern of temperature and other weather trends. So think about the 4 seasons we experience: summer, spring, winter, and fall. We experience seasons due to changes in the intensity of sunlight and the number of daylight hours as the Earth revolves around the sun. So how direct is that sunlight hitting us, and how many hours do we get the sunlight? At an equinox, sunlight shines equally on the northern and southern hemispheres. Half of each hemisphere is lit, and half of each hemisphere is in darkness. We have 2 equinoxes per year. As Earth moves around along its orbit, the sunlight reaches more of one hemisphere than the other, and that's called a solstice. The area of sunlight is at a maximum in one hemisphere and at a minimum in the other hemisphere. We have 2 solstices each year too. We have a winter solstice and a summer solstice. During the September equinox, sunlight shines equally on both poles. So a day in September, we have an equal amount of sunlight on the north and south poles in northern and southern hemisphere. During the March equinox, half of each hemisphere is lit and the sunlight is centered on the equator. At the December solstice, or the winter solstice, the North Pole leans away from the sun. We're in the northern hemisphere, so we're away from the sun, and it's in complete darkness in the North Pole. The South Pole is at its point in which it's in complete sunlight because it's summertime in the South Pole, December. At the June solstice, or the summer solstice, the North Pole leans toward the sun. It's in complete sunlight, and the South Pole is in complete darkness because it's leaned away from the sun. All right, let's look at the different solstices here. So we have 2 solstices. We have a June solstice and a December solstice. December, which is where we just came from, the December solstice, we are experiencing our shortest day as far as daylight hours go. We still have 24 hours in the day. However, we're talking how many hours do we have sunshine, okay? So our shortest in December, longest in June, because look how much more of the northern hemisphere is lit up. Do you see how this North Pole area is not in light and this North Pole area is in the light? Okay, let's look at the March equinox. You have a northern and southern hemisphere directly down the center. See that light shining on the Earth? And then over here, same thing. North and South Pole, same amount of sunlight for the same hours, equinox. All right, I want you to go to page 250 and 251 and do numbers 11, 12, and 13. Pause the video.